Okay, these are the notes for using sine, cosine, and tangent when finding missing sides of a triangle. So previously we did finding missing angles. And remember, when you find missing angles, that's when you use the inverse or the second button on your calculator. So we already went through all of these, and we should be right here, which is slide number 10 for your notes. And again, we'll spend 2 days on this, so you can watch this video as many times as you like. Okay, so this first problem, which is on slide 10, is basically giving you one angle and one side. So I have a hypotenuse. Now again, I'm going to do this just to start off. Whatever angle they give you, that's where you are. So if you want to draw the stick figure, that's where you are. If I look out, x is opposite of me. 15 is a hypotenuse. So again, if we do our little cheat sheet, SOHCAHTOA, remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So right now, the only one that I have is an opposite, which is x, and a hypotenuse, which is 15. That means I'm using sine. So the way that I set this up is I use a proportion, because you guys have been doing proportions since you were in middle school. But when you write this out, you are standing here, you are going to use sine of a 72-degree angle. So I'm going to write sine 72. Now that is a number, so I'm going to put that number over 1. Now it's a fraction. I'm going to set it equal to the opposite over the hypotenuse, and that's how I'm going to do my proportion. So I'm going to go ahead and replace the opposite and the hypotenuse with the letters and the numbers. The opposite was x, the hypotenuse was 15. How do you do proportions? You cross multiply. So 1 times x, or x times 1 is x, equals, now here's where it's a little bit different. You're just going to multiply these two numbers, but on your calculator, you are just going to hit the sine button, not second sine. You're just going to hit sine and then 72. What you'll notice on your calculator is it will give you a left parenthesis. You need to close that parenthesis and then put 15. Now you are multiplying sine 72 by 15. If you want to put a times sign after the parentheses, you can. It does not matter. All right, now I'm going to go to my calculator, and I'm going to bring up the same thing, but always make sure your calculator is on degree mode. And again, make sure you're bringing calculators to class. So I need to make sure that I'm on degree mode. Right now I'm not on degree mode. Go down to the third one, put it on degree, hit enter, and now you're ready to go. So I should be able to hit sine. And again, notice how it says sine, not sine to the -1. 72. Now, I'm going to close the parenthesis. Right now, my parenthesis is not closed. And then I'm going to hit 15 and then hit enter. I want the answer rounded to the nearest tenth. So 14.26 becomes 14.3. Okay? All right. So this answer, x is equal to 14.3. And I'm literally just going to go through these problems here. They're all the same. Use your cheat sheet every single time. SOHCAHTOA. All right, let's go to the next one. Okay. Again, it's a right triangle. Wherever the angle is, that's where you are. You do not have to keep drawing this stick figure. X is right beside me. That's adjacent. This is a hypotenuse. Which one uses an A and an H? And again, if you wrote down SOHCAHTOA, it's cosine. So again, we're making a proportion. I'm standing here at a 35-degree angle. So I'm going to use cosine of a 35-degree angle. That is a number. Put it over 1 equals adjacent over hypotenuse. But who was the adjacent? The adjacent was x. Who was the hypotenuse? It was 10. Literally all you're doing is multiplying these numbers. So it's x over 10. X times 1 is just x, so x equals cosine 35. Your calculator is going to give you a left parenthesis. Make sure you close it, and then do times 10. So again, I'll go back to my calculator, clear this. This time it's cosine 35, but close the parenthesis. The right parenthesis is right above number 9, and then hit 10. Then hit enter. 8.19 rounds up to 8.2. All right, so this x, this side right here, x should be 8.2. So we've seen a sine problem and a cosine problem. Let's see what the next one is, a tangent problem. Okay, again, wherever the angle is, that's where you are. You look out this way, that's an opposite. You look that way, that's an adjacent. Who uses O and A? Tangent. So you're going to do tangent using a 51-degree angle, because that's where you were standing, make it over 1, equals, now I'm not going to write O over A. Who was the opposite? That was X. Who was the adjacent? That was 23. Every time the variable's on the top, literally you're just going to multiply tangent 51 by 23. X equals tangent 51 times 23. And again, let's go to the calculator. Clear this one. And, sorry, go back and do it again. There he is. I probably got to change my mode again because it reset. Yep, so be careful. Make sure you do that. All right, second quit. All right, so we had tangent 51, close the parenthesis, and we multiplied that by 23. And your answer should be to the nearest tenth, 28.4. And again, do these in your calculator and make sure you're getting the same answer that I am, 28.4. All right, so x is equal to 28.4. X equals 28.4. All right, let's go to the next one. Now, this one's going to be a little bit different because I don't think the variable is going to be on the top. You're standing here. And again, if you don't want to draw the stick figure, you don't have to draw the stick figure. That is opposite of me. That is a hypotenuse of me. Opposite hypotenuse is always sine. So this one's going to be a little bit different. You're going to use sine of a 40-degree angle. That's a number, so put it over 1. Equals, now remember, it's opposite over hypotenuse. O over H. But who was opposite? 6. Who was hypotenuse? X. This one's different. The variable's on the bottom. When the variable's on the bottom, this is why I like doing it this way with proportions. Sine 40 now goes with x. So sine 40 is a number. It's not 40, it's sine 40. So sine 40 times x is just sine 40x. 6 times 1 is 6. But what would you do to get x by itself? You wouldn't divide by 40, you divide by everything that's connected to x. That is sine 40. So if you divide the left side by sine 40, you got to do the same thing to the right. Divide it by sine 40. These cancel. So x is equal to, we need to take our calculator, and this time instead of multiplying, we're dividing. It's going to be 6 divided by sine 40. Let's go back to it, clear it. 6 divided by sine 40. Now when you're dividing, you technically at the end don't have to close the parentheses because there's no other number coming after that 40, but it's up to you. It's just good practice to do it. So 6 divided by sine 40 gives us 9.33, which still rounded is 9.3. All right, so remember, if variable's on the bottom, like it was here, you're going to divide. So that answer is 9.3. All right. Let's go to the next one. Same thing. I'm just going to put a circle. That's where I'm standing. This is adjacent. This is hypotenuse. Who uses adjacent and hypotenuse? Cosine. So if you do it as a proportion, I don't see how you can mess this up. It's cosine 37, make it a fraction, put it over 1, equals adjacent over hypotenuse. But who was adjacent? 11 over x. These two go together. Remember, you cross multiply. So that's cosine 37x equals 11. How would you get x by itself? Divide by cosine 37. Well, if you divide the left side by cosine 37, it's the same thing. Divide the right side by cosine 37. These cancel. So x is equal to, take your calculator and do 11 divided by cosine 37. Let's see what we get. So 11 divided by cosine 37. You can close the parenthesis. enter. 13.77, that rounds up to 13.8. So we get 13.8 for this answer here. All right. All right. Now again, this one's a little bit different. This time, if this was a pole or a tower or whatever, the guy's standing up here. So when he looks right here, that's right beside him. That's adjacent. And that's opposite. So who uses a O and an A should be tangent. So again, we're going to use tangent. And where I'm standing, it's a 28-degree angle, so it's tan 28 over 1. But remember, tan 28 over 1 is equal to opposite over adjacent. Who was opposite me? That was 39. Who was adjacent? That was x. Again, if variable's on the bottom, ultimately it means you're going to divide. So tan 28x, hopefully you do enough of these problems, you realize that, equals 39 times 1, which is 39. How are you going to get x by itself? Divided by tan 28. Literally all you're doing with these problems is either multiplying two numbers or dividing two numbers. That's all you're doing. It's pretty simple. These cancel. X is equal to, we need to do 39 divided by tangent 28. So let's clear it. 39 divided by tangent 28. Close it. 73.3. That should be your answer. All right, so x is equal to 73.3. Okay? All right, let's go to the next one. I'll work one more out, and then the rest of them I'm just going to show the proportion and give you the answers. Okay, so again, you're here. If you want to draw the stick figure, you can. It does not matter as long as you understand. What is x to me? That's the farthest away. That's an opposite. What is 18 to me? That's an adjacent. Because remember, the hypotenuse is the biggest piece, and this is the hypotenuse right here. So I only have an opposite and adjacent. Well, what uses opposite and adjacent? Tangent. So we're going to use tangent 25 over 1 equals opposite over adjacent. So opposite was x, adjacent was 18. And again, this one goes back to what we did originally. The variable's on the top, so x times 1 is just x. So again, you're not dividing this time. It's just going to be tan 25. They'll give you a left parenthesis. Make sure you close it. Times 18. So tan 25 times 18. Close a parenthesis. 18. Hit enter. 8.39, but 8.39 bumps up to 8.4. So x is equal to 8.4. Okay? Now again, as I'm just setting these up, I'll give you the answer. But again, double check, make sure you're working these out with your calculator so you can make sure you get it right. All right, you're standing up here. This guy's right beside you. He must be an adjacent. This guy's a hypotenuse. So who uses an adjacent and a hypotenuse? That's cosine. Cosine 70 over 1 equals, who was adjacent? 15. Who was hypotenuse? X. Variables on the bottom. I bet I'm going to divide. So cosine 70x equals 15 times 1, which is 15. How do you get rid of the cosine 70 attached to the x? Divided by cosine 70. So you're really doing 15 divided by cosine 70. I'm not going to switch back to my calculator, but if you do 15 divided by cosine 70, x should equal 43.9. And that should make sense because that's the hypotenuse, and the hypotenuse should be the biggest piece of the triangle. So 43.9. And then let's just do these last three real quick. All right, there I am. Opposite hypotenuse is sine, so katoa. So sine 52 over 1 equals the opposite is x over 15. Again, x times 1 is x, so really what you're doing is just multiplying sine 52 by 15. And if you do sine 52 times 15, x is equal to 11.8. And let's look at number 2. You're standing here. He's adjacent, he's hypotenuse. Adjacent hypotenuse, that's a cosine. So cosine 37 over 1 equals adjacent, which is x, over 14. Again, if variable's on top, you're just multiplying. That's it. Cosine 37 times 14, x should equal 11.2. And then the last one, I like the last one because it shows you two different ways you could get this. They actually gave you two angles here. So if I started with this angle, that's adjacent and that's hypotenuse, so that would be cosine. So that would be cosine 36 over 1 equals x over 17. And if you multiply cosine 36 by 17, because x times 1 is x, you should get 13.8. But if you didn't feel like using that angle, you could have used this angle here. But now this is opposite. This is hypotenuse. So who uses an opposite in a hypotenuse? That'd be sine. So that'd be sine 54 over 1 equals x over 17. And the nice thing about this problem, when you multiply these two, you get the exact same answer, 13.8. That's why it has to work. All right? All right, you guys.